A rectangular channel is of 3.2 meter wide and 10.5 meter deep. Find the channel bed slope to be maintained to carry a discharge of 65 cubic meter per second. Take Chedji's constant as 60. Width of the rectangular channel is 3.2 meters. Depth of rectangular channel is equal to 10.5 meter. Discharge through rectangular channel is 65 meter cube per second. Chedji's constant is equal to 60. To calculate the channel bed slope, use the formula for velocity of flow. V is equal to C into root R/S, where R is hydraulic mean depth, S is the channel bed slope. C we know, Chedji's constant. Write the formula to get the hydraulic mean depth. R is equal to area of the rectangular channel divided by wetted perimeter. Area of the rectangular channel, capital A, is equal to B into Y, bed width into hydraulic depth. B is 3.2 into 10.5. Area is 33.6 meter square. Wetted perimeter. P is equal to B plus 2 into Y. 10.5 plus 2 into 3.2. P is 16.9 meter. Therefore, hydraulic mean depth R is equal to A by P, that is equal to 33.6 divided by 16.9. It comes to 1.988 meter. Substitute this R value in V is equal to C root RS. We know Q is equal to area into velocity. V is equal to Q divided by A. Q divided by A is equal to C into root RS. Where Q is given in the question 65 meter cube per second. Area just now we have calculated 33.6 meter square is equal to 60 into R value 1.988 into S. 65 by 33.6 is 1.934 is equal to 60 into root 1.988 into root S. Root S is equal to 1.934 divided by 60 into root of 1.988. Root S value is 0.02286. Square on both sides. S is equal to 0.02286 whole square. S value is 5.225 into 10 power minus 4. So S can be written as 1 in 1913.5. That is equal to 1 in 1920. Channel bed slope is 1 in 1920. A rectangular channel is 3.75 meter deep and 6.75 meter wide. Find the discharge in liters per day through the channel when it runs full. Take the slope of the channel bed 1 in 1400 and Chedji's constant as 50. The rectangular channel is running full. This is the bed width of rectangular channel, capital B. This is the hydraulic depth, Y. In the question, the width of the channel is 6.75 meter. Depth of the rectangular channel is 3.75 meter. Channel bed slope S is equal to 1 in 1400. We write it as 1 divided by 1400. Church's constant C is equal to 50. Area of the flow through this rectangular channel, capital A, is equal to B into Y. 6.75 into 3.75. A is equal to 25.312 meter square. Now calculate the wetted perimeter. Capital P is equal to B plus 2Y. Wetted perimeter is the overall length of the rectangular channel through this way. This is Y, this is B, and this is Y. From here to here Y, and from here to here B, from here to here Y. We get B plus 2Y. 6.75 plus 2 into 3.75. 14.25 meter. Hydraulic mean depth. Hydraulic mean depth R is the ratio of area of the rectangular channel to wetted perimeter. 25.312 divided by 14.25. Therefore R is equal to 1.776 meter. Velocity of flow using Church's constant V is equal to C root R into S. C is given as 50. Square root of R is 1.776 into S, 1 by 1400. Therefore V is equal to 1.78 meter per second. Discharge through rectangular channel Q is equal to area into velocity. Area is 25.312, velocity is 1.78. The rate of flow is 45.055 meter cube per second. A rectangular channel carries water at the rate of 1.234 cubic with a longitudinal slope of 1 in 1000. Determine the dimensions for the most economical channel section. Take Church's constant C is equal to 55. Let's write down the given data. Rate of flow through rectangular channel Q is equal to 1.234 cubic. 1 cubic is equal to 1 meter cube per second. Longitudinal slope, say it is S, is equal to 1 in 1000. That is equal to 1 by 1000. Church's constant C is equal to 55. We have to find the dimensions of the rectangular channel. This is the rectangular channel cross section. This is bed width of the rectangular channel. This vertical depth is depth of the channel section. For the most economical rectangular channel section, apply the two conditions. First one is Y is equal to B by 2, where Y is depth of the section, B is width of the section. Therefore B is equal to 2 into Y. Let it be taken as 1. And second condition is R is equal to y by 2, where R is hydraulic mean depth. Discharge through rectangular channel Q is equal to area into velocity. Cross sectional area of rectangular channel section is B into Y. We know B is 2y into y. A is equal to 2 into y square. Velocity of flow through the rectangular channel section V is equal to C into square root of RS. The edge is constant given as 55 root R. R is y by 2. S value, longitudinal slope of channel section is 1 in 1000. Therefore V is equal to, take this y outside, square root y into 55 square root of 1 by 2 into 1000, 2000. V is equal to square root y into, this value is 1.229. Therefore V is equal to 1.229 square root y. So it is 3. From 2 and 3, discharge through section can be written as A is 2y square into V is 1.229 square root of y. 2 into 1.229 into y square into y power 1 by 2. Y square into y power 1 by 2. Q is equal to 2 into 1.229 into y power 2 into y power 1 by 2, that is y power 2.5. We know the discharge value that is given in the question, 1.234 meter cube per second. Substitute here, 1.234 is equal to 2 into 1.229 into y power 2.5. Y power 2.5 is equal to 1.234 divided by 2 into 1.229, which is equal to 0.502. Y is equal to 0.759 meter. We know B is equal to 2y. Substitute this y value here. B is equal to 2 into 0.759. B is equal to 1.518 meters. For the conditions given in the question, the most economical section of rectangular channel should have the bed width of 1.518 meters and depth is equal to 0.759 meters. A rectangular channel having most economical section is 6 meters wide. Find the discharge if the bed slope is 1 in 1200. Assume Chedju's constant as 50. The given section is rectangular channel and it is the most economical section. The width of the rectangular section is given 6 meters. Y is not given in the question. We have to find out it. The bed slope is given. S is equal to 1 in 1200. Chedj is constant. C is equal to 50. For the most economical rectangular channel section, the conditions are, first one is y is equal to b by 2. Here y is the depth of the rectangular channel, b is the width of the channel. Y is equal to, b is the 6 meters, 6 by 2. Therefore, depth of channel is 3 meters. Second condition is R is equal to y by 2, where R is the hydraulic mean depth. R is equal to 3 meters by 2. r is equal to 1.5 meters. Velocity of flow through the rectangular channel is written as c into root rs. We know c value 50 into root r is 1.5 and s is the bed slope given in the question, 1 in 1200, that is 1 by 1200. V is equal to 50 into this value is square root of 1.5 divided by 1200, 0.0353. Therefore velocity of flow is equal to 1.765 meter per second. Now find the discharge through the rectangular channel. Q is equal to cross-sectional area into velocity of flow. The rectangular channel cross-sectional area is B into Y. B is 6 meters and Y is 3 meters. Velocity of flow is 1.765 meter per second. The discharge comes to 31.77 meter cube per second. For the most economical rectangular channel section, discharge is, for the given conditions, discharge is 31.77 meter cube per second. A rectangular channel having a discharge of 2.345 meter cube per second when the channel bed slope is 1 in 7890. Find the most economical dimension of the channel if Manning's constant n as 0.12. Let B is equal to width of the rectangular channel. Y is equal to depth of the rectangular channel. R is equal to hydraulic mean depth. In the question, discharge is given. .345 meter cube per second. Channel bed slope S is equal to 1 in 7890. Manning's n 0.012. For the most economical rectangular channel section, the applicable conditions are Y is equal to B by 2. Second one is R is equal to Y by 2. From this, B is equal to 2Y. Write the discharge formula through the rectangular channel section. Q is equal to area into velocity. Here A is the cross-sectional area of the rectangular channel section. A is equal to B into Y. We know B is 2Y into Y. Therefore A is equal to 2 into Y square. Now calculate the velocity of flow through rectangular channel. Using this Manning's constant, V can be written as 1 by n r to the power of 2 by 3 s to the power of 1 by 2, where r is the hydraulic mean depth and s is the longitudinal slope. N is the Manning's constant. 1 by 0.012. R is equal to y by 2 whole power 2 by 3. S is 1 by 7890 whole power 1 by 2. We know y is b by 2. V is equal to 1 by 0.012. Y is equal to b by 2 whole power 2 by 3. 1 by 7890 whole power 1 by 2. V is equal to b power 2 by 3 into 1 by 0.012 into 1 by 4 whole power 2 by 3. 1 by 7890 whole power 1 by 2. Therefore V is equal to B power 2 by 3 into the value of this is 4.182 into 10 power minus 3. Now substitute this V and A in discharge formula. Q is equal to A into V. A is equal to B into Y into velocity is B power 2 by 3 into 4.182 into 10 power minus 3. B into, we know Y is equal to B by 2 into B power 2 by 3 into 4.182 into 10 power minus 3. B into B, B square, B power 2 by 3 into 4.182 into 10 power minus 3. Therefore Q is equal to B power 2 into B power 2 by 3. That is B power 2 plus 2 by 3, 8 by 3. B power 8 by 3 into 1 by 2 into 4.182 into 10 power minus 3. We know Q value 2.345 meter cube per second is equal to B power 8 by 3 into 4.182 into 10 power minus 3 by 2. B power 8 by 3 is equal to 2.345 into 2 divided by 4.182 into 10 power minus 3. Therefore B power 8 by 3 is equal to 1121.472. B power 8 by 3 whole power 3 by 8 is equal to 1121.472 power 3 by 8. Then we get the B value 13.921 meter. Round it to 14 meters. Calculate the depth of channel section. Y is equal to B by 2. Y is equal to 14 by 2. Y is equal to 7 meters. So for the given discharge, the most economical rectangular section have the dimensions of 14 meter bed width and 7 meter depth.